didn't know what it was, they call it ether.
5, 4, 3, 2. Your mom's box. It's time. You're tuning in to Chocolate Smoov and Chappsticc in the morning, evening, and night. But night and evening is the same thing.
Chocolate Smoov and Chappsticc.
Nipples in a basket. I'm Chocolate Smoov.
And I'm Chappsticc.
I'm keeping it nice and smooth.
And I'm keeping it moist.
Every day, every night.
And every noon and every midnight around the same time.
And that means evening.
Around that general
When the sun
zone.
goes down.
Eastern Standard Time.
For real though, because Western time is for the birds.
I mean, that's another 5 hours.
If
I gotta
you're-
keep track of.
If you're in the West Coast, then, to be honest, East Side, but not a gang thing, but East Side.
We represent. We're probably gonna have to cut that out. But
Yeah.
anyway,
That was a gang thing. Probably need to cut the gang thing out. But maybe we'll keep it. Who knows? Probably not though. But
anyway.
I don't want to get murdered if I do like a show in Miami.
Uh,
And they're like, "What you say, Holmes?" And be like, "Oh, West Side, dog."
what, the Latin Kings are gonna come after you?
Yeah, dude, Latin Kings are on the West Side, dog.
I thought Latin Kings were all just like Hispanics that came
Maybe,
together. and,
maybe
like,
they're just everywhere. I don't know. I'm not a gang guy. Not big on the whole gang thing.
What? You never been like gang culture? You
not a-
never like dipped into it?
No, not really. No, no. I think.
Wow,
Yeah, people. But really, it's not because I didn't want to.
what a narc.
No, but it's not because I didn't want to, and it's not because I did not want to, but I didn't want to.
Snitches get stitches.
But I
bro.
also, this is the thing. Nobody asked me.
Well, I mean, you
If somebody asked me, I might never know.
do you need to be invited to a gang? And if
Yeah.
so, is that technically a gang or a club?
You don't just get to get into a gang, though.
Is that a club or a gang?
But this is the thing, right? You don't just walk up to a gang and be like, "I want to be in." You don't want, and I don't know why I said it like
I
that,
think-
but you don't
I
say
think
that.
they have to walk up to you and be like, "All right, you're in," and you're just like, "What? What are you talking about? What am I in now? You're in the gang. You beat up our leader."
No, because they
That's how it usually works in
No,
Chinese
because
movies.
that's Riddick. That's
That's true. That's very
yeah.
very
That's
true.
not. That's a Vin Diesel movie, not real life.
I mean, it could also be real life.
No, that's just not real.
Most stories are based off of a true story.
That's also not true.
That's very true. What are you talking about?
Most stories are not based on true stories. Most stories are based on. I bet there's more fiction than non-fiction.
Oh yeah, but it was based off of a general idea.
But how
that was...
fucked is it that they call it fiction? Because fiction could be misconstrued as fact. And when I was a kid, I also probably am still a little retarded, but I definitely thought fiction makes more sense to be mean factual books. But it does not. I think that's super dumb. Why would you make it like that?
What do you mean?
Why would you be like, "Oh, this is not a fact and this is a fact." But to call it a fact, you're calling it a non-something. It should just be called a something, and then whatever is not that something is a non-something.
What, you mean like fiction and non-fiction in the library?
That's literally what I was saying.
Oh, okay. Sorry, I got off
Literally-
track because you were explaining it way too hard.
Literally, I just said that.
No, I understand, but I'm just saying.
But
like,
isn't that dumb?
No, because more fiction books are written because people have more fantasy ideas than reality ideas.
Okay,
because
but-
people are trapped in the
But
reality.
shouldn't that be
they live.
called? Shouldn't fiction be called non-fiction?
No, fiction is fiction because it's not real.
Yeah, but fiction should mean real. They should just switch the term of it.
No, because fiction is... you can't just switch something that's been the same for the last at least 600 years.
I get that, but
believe.
whoever did it, I'm saying, is an idiot. They just weren't thinking the way it plays out.
No, it was just a system like fiction and nonfiction, works of fantasy and works of non-fantasy.
Yeah,
Like,
but fiction should be called nonfiction, non-fantasy.
what are you talking
I
about?
don't know, but I'm just saying it really always bothered me. I'm also dyslexic, so it's cool.
You're not dyslexic.
So,
You
anyways,
just don't like reading.
this podcast coming up is about the great,
And powerful.
the mighty,
The beautiful.
the greatest, one of the greatest human beings to ever walk this earth.
He's about 5'4" and a philosophy major who has a master's.
Who was in the Navy and lived a life and is still living a great life.
Hey man, old and proud, old and proud.
Old and proud. We call him Ed. We're not going to give you his last name because you're going to Google him.
That's creepy, man.
And nothing's going to come up.
Yeah.
Yeah, it's just pointless. His name is Ed. He's our dear, dear Chappstic's godfather.
Love him.
And he's a good friend of mine. Partially a godfather because his parents are basically my parents.
Yeah.
Chappsticc here is basically adopted, and I'm the real one. I mean, I have two parents, and really the reason why I have two parents
It's not true at all.
is not because my parents got divorced, because they're two separate group of parents. I have a mom, and then I have a mom and a dad. They're two separate people in lives. I have a mom that I was born from and raised me, and then I have another mom and a dad that came from basically because they thought I was better than their son, and they were like, we definitely need to keep this guy around. So they kept me, and then they just put up with Chappsticc because...
I invited you in my home.
Yeah, but your parents kept me.
I mean, I convinced them to let you stay.
And then they kept me. So it's not about you. You're just trying to make it about you. But it's really about me.
Oh my god.
And this is the thing. Ed is a great person. He is a philosopher. And he is a guy that thinks so deeply about things. And so deeply that it even bothers him and keeps him up at night.
Yeah, this
and
man
he
literally
stays up till 2, 3 in the morning just researching and looking at things. And he's an awesome person, beautiful human being, and has some really great insight. And this episode coming up is really just, we're going to call it basically our little science bits where we just get stoned and we talk about all of our thoughts and all of our things about the universe, space, time, everything that you can really come to light and think about, and things that are new in science that are exhilarating and that really just, you know, there are opinions because that is the beauty of science, is that it is not for sure, and that there can be people who are philosophers and people who are go through theory and people that sit and think about things based on the scientific learnings that they've discovered.
That's true. Science is just trial and error. 95% of the time, it is just trial and error, and no matter what, you don't know what's going to happen. I mean, if you pour some water on some table salt, but it's pure potassium chloride, that thing will explode. So you have no idea what could happen. It's just all theory.
And this is the thing, right? This is the thing you have to realize. The information that you're getting from this man is a man that was through many things. He's been through war. He's seen the celebration of Pearl Harbor. He was there in history.
He's lived such a very colorful life. He grew up in Los Angeles. He basically shooed his way into the Navy because he was underage, and he went to Hawaii. He went all around the states. Not a lot of them, but just a couple of them that he just, he wanted to travel.
To Asia.
Yeah, and to different continents around the world. It's just a very, very beautiful, very fruitful life that he's accumulated.
Around the time that this man was a baby, shortly after he was born, or shortly before, I should say, he was born, Pluto was just discovered as a planet.
Mm-hmm.
They thought this thing was a planet. So only think how far the world has come through this man's eyes. What has progressed? Color TV, people.
Microwave. The A-Track. Walkmans.
Everything.
And now we have
Construction guys and Nextel phones.
Yep.
He's lived through it all.
Can you hear me now?
He ran and basically wrote the book on the safety and procedures for nuclear power plants. The man has lived a life. So listen to this podcast, enjoy. It's a short little brief talk and collection of thoughts of one of the greatest men, whatever you want to call him, alien from this planet, to ever live. And it is an honor to be able to even record these items of Ed.
It's just kind of 1 in a million, 1 in a billion, honestly, because of what just a special person. So here's our first episode of Science Ed.
So
Enjoy.
Boltzmann brain is, and I think this is complete BS and not possible at all. But so the Boltzmann brain theory or is essentially that that all of our memories and everything that happened technically didn't happen. Because if string theory is correct, or if string theory is correct where there's multiple possibilities and everything, right? Technically our past didn't happen. If we're a Boltzmann brain society where we are, and that's what science is, that we are Boltzmann brains, it's basically all the neutrons and protons and whatever is essentially like gas in a jar, where if you put gas in a jar and time went through infinitely, eventually there would be a moment because the gas is, bouncing around in all different directions, right? And that's why it's not a solid, or, you know what I mean, or it would be in one singular place. But at some point in time, all of those particles, if you were to leave it for the lifespan of the universe, would be, they would eventually accumulate at some point all in one spot. So the Boltzmann brain would mean that this interaction that we're having right now and the words that I just said only happened in that moment, and were just spontaneous moments happening in perfect alignment of the universe. And as the universe expands, that dissipates, and that's why the universe is ever expanding, and eventually we will all just end in a silence.
It's like an explosion, and then after the explosion, the aftershock, and then after the aftershock,
well, it's
you
just
hear the thunder,
we are in
and then that's it.
It's like saying that we're in a simulation, right? That nothing is actually real. Everything that happened, that's happening right now, is just a bunch of particles and molecules that are going slam together and bouncing around, and this is what's happening right in that moment. But it didn't happen, and all of our memories and everything is just an accumulation of all of those chemicals and all those molecules bouncing around, and we're just a moment.
I can understand it for the future, But if you've already experienced it, it's happened.
It never happened. And
It did
Boltzmann,
happen.
well, we're just assuming, we're just saying that it
That's,
happened.
that's not intuitive.
Well, I agree. That's
really
why I
way
think
out in the middle of nowhere,
100%.
and you're going to have to figure out,
This is-
mathematically that probably works.
This is the guy that basically started thermodynamics. Because essentially, all the gases are going around
Right.
is that's thermodynamics. That's like the second law of thermodynamics
Right.
is that eventually they'll all end up in one spot. That's
I
the
don't know that. That's one.
but
I
it's
never heard that.
well that's thermodynamics. Is that every
Heat rises, cold falls.
no, I can't think of the scientific term for what that means when all of the gas, like what is a gas? Like what's the name of gas? The molecules bouncing, or the electrons and protons bouncing around inside.
Well, that's just what they're doing right now and everything.
100%. That's why this person
But-
created this theory that everything is essentially just in that moment.
Yeah.
And the word that I just said, it never happened in that moment. We're just in this moment right now. And then what I just said there doesn't happen. So that's why.
Not intuitive.
Well, that's why I even.
Not intuitive.
Well, I agree. That's why I said I think it's BS. Like, but that's just something that scientists have. This was in the
mathematical deduction.
This was in like the turn of like the 19th century or something, or 18th century, that this person, what did I call it? Boltzmann's brains?
Yeah.
Boltzmann brain? Whatever the guy's first name is, I don't know, but his last name is Boltzmann. And he's the guy that it contributed to thermodynamics.
Okay, I've heard the name. I didn't associate him with that.
But that was his big after, what I've noticed in that a lot of scientists is that they actually discover something valid, right? They give their name some kind of credibility, and then their next thing is this crazy, and then they're like, oh, well, this is the moment for me to unleash string theory now. Now that I have this backing, you know what I mean? Or like
I say, it's got to be, to me, all this stuff they've been talking about in mathematics and all that stuff, it's got to end up intuitive. It's got to be understandable by you and me.
But
Just like the Earth was flat for thousands of years.
But
Then
why
it-
does the
oh, it's
universe
not
have
flat.
the universe, Neil deGrasse Tyson says this all the time, the universe is under no obligation to make
That
sense
makes
to us.
sense to you, yes, I know.
So then anything could be possible when you put it like
But
that, which
But
is
everything
almost like
everything becomes intuitive.
isn't that kind of a
later
cop out when you
on.
say that? Like,
No, because everything
like
has
if
to
you-
mathematically make sense.
well, it doesn't, because in quantum theory, once you get to quantum theory, relativity is out the window.
Exactly, but
So
we're
then
not
it
in
doesn't-
quantum theory. We're in the real world.
No, everything is quantum.
Okay.
Everything.
Am I quantum compared to you?
Yeah, we are all a quantum thing happening. We are a quantum mechanically
No, I mean what you
inside
can
that's
observe,
happening.
what you can physically observe.
We can observe that though.
No, physically with your eyeballs.
That's just physical science.
Looking
and then,
at me.
Yeah, I'm saying that's
Okay.
just physical science. But that is not necessarily, there's an end to that. There's like a limit to physical science.
No, why?
Mm-mm.
Well, what do you mean why?
Well,
That's why
does
they
there
came
have
up.
to be an end to it?
Well,
These guys are making formulas that do all sorts of different things.
yeah, but what I'm saying is like there's a limit to physical science, as in like there's a limit to what we call
No,
a
there isn't.
measurement. Yeah.
No, there isn't. No, there isn't.
Mm-mm.
There's no limit to it. They go down to a Planck time.
And that's quantum.
Yeah, definitely.
Then you're
quantum.
into quantum
but
physics.
the time
That's
it
not-
takes light to travel across an electron.
Is quantum physics.
That's a Planck time. That's a Planck second.
So
Yeah.
they still measure it.
But
Yeah.
in quantum physics, that's not.
It is quantum physics. Yeah.
Yes, but that's not observable. That's not what
It's
you
not
guys are
observable.
saying is.
It's only observable mathematically.
Yeah.
You cannot physically see an electron get covered in light like it does our sun.
Right.
Yeah, obviously.
Well, it's not obvious.
Well, we can't. Well, yeah, because we can't see that. We can't.
Bacteria can see it.
Oh, well, that's true. Maybe because they're so
They're so
small
small,
that they
yeah.
see things at a different.
Because relative to that, the
Yeah.
Electron's probably like a little ant or amoeba that
Yeah.
you can look through a
Moon.
microscope.
Could be a moon. That's
And
true, man.
everything that we observe is only relative to us in our form of motion, right? Because if the only way you can observe something or time or anything, there has to be motion. There has to be something happening. We can observe that the Earth is going around the sun because the Earth is spinning. We don't feel the Earth spinning,
And we don't feel it's going around
but
the sun
we
either.
don't feel it's going around the
We
sun.
don't
Exactly.
feel the
Yeah.
universe going around, well, not the universe, but our solar system going around a central black hole.
And we
Yeah.
don't feel our whole galaxy being thrown like a little
Right.
And we
baseball
wouldn't
across the
know
room.
we wouldn't know any of that if there was nothing to base that off of. So we're basing off of
No,
oh well
Mathematics.
we're
yeah,
moving
yeah.
at this and then
Yeah, but
E equals MC squared,
how
right?
are they determining the distance? From
They're
here, say from here to Alpha Centauri. How do they do that? You
They
can't get a tape measure and just run it out.
yeah, well they could measure how long it took the light to get to us.
How do they
But
know
you
how
need a
long the light
reference
took to get
of
there?
time to start with.
Yeah, you have to have some kind of motion that
And
creates a time
what they're using is what they call the standard candle.
yeah.
How bright something when nova goes off, how bright it is, and they can go by how bright it is, how far away it is. Nothing measured, it's all calculated.
Yeah.
And then the light coming off of it in the red shift, the Doppler effect. Oh. The Doppler shift.
What do you mean?
You know the Doppler effect? When an object is moving toward you, like the sound of a car, it's boom. The change of sound,
Oh yeah, based
It's a
on where
Doppler.
it is relative to where you are, yeah.
the speed with which it's passing you.
Yeah.
That's the Doppler effect, and that's how they measure what's on another sun.
Through the photons passing by us and how long and how fast it takes.
The spectrum, the electromagnetic spectrum, where a type of atom will absorb a certain portion of the light.
Mhm.
And that, we're at, if you take our sun, and you got carbon here, and you got oxygen here in our sun. Well, when you get further away, them carbons are shifted on the scale a little bit. The carbon atom and the oxygen atom are shifted on the scale back where it wouldn't normally be unless it was far away. Because as light travels toward you, the light waves, the photons, are compressed, so they come on the blue side.
Yeah.
When they're going away from you, they get in the red side, the long side, because they're going away. That's the Doppler effect. That's how they measure the distances between
That's the
15
color spectrum
billion
too,
years
yeah.
ago.
Yeah.
But I got another one for you.
I never knew that.
The speed of light is 186,000 miles per second. That's one measurement of it.
Mm-hmm.
But I believe in the general theory of relativity or the special theory, I'm not sure which one. But if the light, oh come on, I'll get it in a minute. Hang on, I got it. It's just one of the things that's bugging me.
You could.
Oh, the speed of light. The faster you go, time slows down.
Mm-hmm.
Also, the amount of gravity, gravitational effect, the light slows down. So if the light's traveling the speed of light, there's no time. So when that light you see in 15 billion light years away, they say, happened just then.
So let me
Because
ask
there's
you.
no time
Let me
for
throw
light.
let me throw this at you, right? One,
Dream of light.
none of us, nobody has ever traveled at the speed of light, correct?
Not that we know of.
So when we say that, oh, there's no time at the speed of light, we are, because you had even said there's definitely got to be something faster than the speed of light,
I know there is.
right? So, well, this is the thing.
They've already just.
So what are we-
You ever hear of inflation?
Yes, I know what the word
Well,
inflation
Well, the
means.
beginning, no, not financial, but inflation, after the Big Bang, there's a period of about a couple billion years that everything moves faster than the speed of light.
Yes. Yes.
There's
Yeah, I
one thing
know.
that
I
moves
do
faster
understand
than the
that.
speed of
Yeah.
light. Okay. What's that one?
Well, what they're contributing that is that there was a
Two
big bang
electrons.
and then something happened.
Oh, I keep forgetting the name. Two electrons that are paired or
Quantum entanglement.
entanglement.
Yeah.
That's faster than the speed of light.
It's
Yeah, so
instant.
what if we only perceive, we're saying, the only reason why we say that there's no time at the speed of light is because it's only relative to what's happening right now, but there could be a whole nother level of time
That's
in
not
regards
intuitive.
to
To
this.
me, that's not intuitive.
Yeah,
it
but
doesn't
you
make
don't
any
even
sense.
know it, though. What do you mean it doesn't make any
I
sense?
don't know nothing.
But
How does that, what do you
so
mean?
hold on. So if you're traveling at the same frequency as that light, you could basically reach out and grab a piece of light. Technically, if you're moving
That's
at the
the
speed
same
of light
frequency.
or at the same speed,
You wouldn't be grabbing light, you'd be grabbing.
you can grab the little
photons.
photons
Yeah,
out of. So technically,
But if there's something faster, then that means that there's time, that provides some kind of time. Because right now
okay,
we're saying that
answer
it's
me. What is time?
time is only relative to to our movement.
What is it? What is it? Give me a definition.
It's a measurement based on movement.
That's exactly right. It's a measurement of movement.
Okay, but if you're saying that there is something that happened that was faster than the speed of light, then that means that if you're moving at the speed of
If you
light,
go faster than
then
the speed of light,
anything
you're going back in time.
that wouldn't make any sense because,
Yeah, it does.
well, hold on then.
Going faster than the speed of light.
Yeah, but okay, so if you had the Big Bang happen and boom, and then whatever to the 10th millionth second, something happened that accelerated everything, which you have inflation, where there was a period where everything was moving super fast at faster than the speed of light. Technically, everything should have been moving back in time then.
Maybe it did.
or forward in time.
So what you're saying, if that's the case, then everything we're doing, we're actually moving back in time. Or not back in time. That all of this could You just blew my mind. I blew my own mind. So then that could mean that if that happened, boom, everything happened, and you're moving back in time, and then everything slowed down. What if something happened to create the Big Bang that reversed everything that ever happened, and we're all just reliving something that has already happened, and the Big Bang just reversed everything, and that's why there's deja vu and things and moments that you feel that have already happened, and then eventually one day we'll get to the end, and then there'll be another Big Bang, and we'll all relive. All of history will redo itself. And we're forever bound in our decisions and our choices because we're stuck in that timeline.
My theory on that
What?
is that the black hole, they're surrounded by an area of demarcation where you have the what they call it,
Event horizon.
event horizon,
Mm-hmm.
and it goes down into what they call a singularity.
Mm-hmm.
Once it crosses the event horizon, it's lost to us for most reasons. That's common right now. That's basically what everybody's saying.
Yes.
I say when it has gained enough mass, a black hole or a hole, gained enough mass to trap light, to be strong enough to maintain light within inside of it.
It could do that at the size this big.
Possibly.
Even a
And
pinhole.
then when it hits, when a particle of matter crosses the event horizon, it's already got enough to stop light. So I'm saying it's sent down into the singularity and immediately shipped out the other side through a white hole.
Which
And
is
now
that
it
the Big
changes
Bang
from-
moment?
It changes from mass to pure energy. And only mass can't travel but faster than the speed of light.
But energy. can.
Energy, I don't know, can it? It seems like it might. I
Yeah.
asked a question a couple months ago. What's the speed of heat? You looked it up. And
Oh yeah. Heat. I
That's energy. That's
Yeah.
pure energy.
That's
It's
true.
not particulate. That's pure energy.
Heat travels almost instantaneously. It just depends on what it's traveling into.
So now let me actually stop you there. Yes. Well, yeah. So when we have a rocket, when you're saying heat is energy, so when we have a rocket and the rocket shoots all that fuel out and you see that big fire mass and that lifts the rocket up into the sky, the only reason why that's doing that is because the molecules around the rocket and that where the gas is coming out and that fire is
all
happening is
based on
cooler.
Mass times velocity.
Well, no,
No,
the way
mass times velocity. It's all it is.
hold on, let me finish. In thermodynamics, there is mass times velocity, but that would never work if everything was just as hot as the fire that you were just expunging.
If you're converting
Nothing
it-
would happen because there's nothing to. I don't know how I'm describing, but that is a real fact.
You're mixing
of
rocket,
No, that's
rocket
not.
science and thermodynamics.
Well,
because
no,
that's not how a
I'm
rocket
saying
works.
that's exactly how a fire and how something is able to rise off the ground works.
Right. So if you have a fire and you throw it in another fire,
It will the fire would not lift something off the ground because
no, just
everything
make
in
a
that
bigger
area.
fire.
100%.
Yeah.
Yeah, but you wouldn't get a rocket off the ground if everything was the same temperature as the fire that you're starting.
Oh, you could.
That's impossible.
Yeah, you could.
So now, anyways, besides all this, I have a pretty cool theory, because Dakota's wrong, but
What do you think of my white hole theory?
yeah, no, it's very possible. We have no idea.
It's very intuitive.
Very what?
Intuitive.
That's what I think.
I think so.
Well, I mean, it's possible,
Anything's
that's
possible.
but it's also possible that at
But
the
they've
end of
already
every
disclaimed it. They've already thought about that, and they've already disclaimed it
Yeah.
for some reason.
well, yeah, that is
I
true.
don't know why.
I think they only disclaim it because
No, because it violates Einstein's theory of relativity.
but also and density of the black
And
hole
that
and
may
everything like
be-
that.
And that will probably change. There are certain
Of
things
course. Oh yeah.
in special theory and a general theory, or
Think about science when you're a kid growing up to what it is now.
no comparison.
Yeah, and at all. So I mean, of course things are going to change, and you know what I mean. I agree with that completely. Now I've been thinking a lot about whatever you want to call it, dark matter, dark energy, whatever you want to call what most of space is made of, right?
Well, there's dark matter and dark energy.
Well, what is the stuff we don't know about? Both.
Both.
Both
Yeah,
both of them. So, anyways, that what if? Because all right. So, Einstein said that wasn't it Einstein that said space and time are the same exact thing, right? Was it
They're
Einstein?
a combination.
Mm-hmm.
Well, no,
They're
space
space and
time.
time,
Well,
yeah.
space time, right, is all one thing, right? But and then there's Newtonian physics that says there's gravitational waves, right? So what if
Einstein also predicted the wave.
did he do that too?
Yeah.
Okay, so what if? And essentially, when I was listening to that Sean Carroll or whatever, he said that essentially. Space and time and gravitational waves can kind of be grouped into the same exact thing because we're moving on a plane of the gravitational waves. We're just moving on that plane. Like if you put a flat piece of paper and then the planet you've ever seen that model where like the planet's in the center and gravity's moving around the planet because of the whatever, right? But what if dark matter or dark energy is that gravitational wavelength? What if everything, all that, because dark matter's in the air right now, right where we are, there's dark matter. It's not just in space, it's everywhere, right?
Yeah.
So what if dark matter is just that gravitational wavelength that we move through? And that's why
That would be for dark energy, but I don't think that would apply to dark matter.
Yeah, but we only say dark matter. It's not a thing. It's not a physical
we can tell-
thing.
we-
We
well,
move through.
We
Well,
know, yeah, we move through it.
we
know
move
it's there.
through it, and we know it's there. But we also know gravity's there, and we also know that we move through this plane of gravitational waves.
Change
So
the
why
subject
can't it
of
be the
of
same thing?
neutrinos. 13 trillion neutrinos go through your thumbnail
Yeah,
every second.
yeah,
That's pretty damn, that's a lot.
yeah.
That's an awful lot of them.
It
And the
is.
whole universe is like that.
It is at a constant.
All the time.
Yes.
So they gotta be doing something, and they're matter. They have a little
Yeah.
bit of matter to them.
What if it's just a ghost world? What if that's the world where all the ghosts live and all the dark matter's just ghosts moving around?
I
And
don't
that's
know.
what neutrinos are.
That's beyond my
Take it to
education.
the different level. Yeah, I don't know, but I was just thinking that what if, because what we quantify currently, or I
What
guess
they
there's,
quantify
or they
currently.
quote currently that gravitational wave, that we are moving on a gravitational plane through
Space-time.
space-time, right? And that's that, right? So what
Well,
if
yeah, but
all
the
that
trouble
is,
what that is, when they show you a model.
what if everything is made up of a gravitational wavelength? That's what I mean. Not itself, because we describe
Well, no.
our gravity as, I don't know, I'm just not describing this right, how I'm trying to put it. Because I don't even know how to put it to where you'd understand it, that I was thinking about it. But because if you go with current science, we're all moving through this plane of existence that is gravitational wavelengths.
No.
That's what science
It's part
says.
of it. No, that's part of it. Yeah, we're in a gravitational wave. We have to be.
No, we're on a no. It's not that we're on a
That
gravitational.
pin is putting out gravitational waves.
Mm-hmm.
Yes, no, but what I'm saying is not that individual. Obviously, we know that through size and all
It's
that
all
that
combination.
things provide gravity. But what I'm saying is, what if that thing that we call gravity, or this thing that we call space and time, is just one big wavelength? That's just, and when I say wavelength, it's not putting. That's what they're calling it, but you're thinking of like
Yeah.
a wavelength of like things. I'm talking about the whole universe is this sheet of paper, and this thing is moving, and this is shaping and moving around this, which is what we, and then this object is so big that we're saying that this is gravity, but really everything else is gravity, and everything else is this, and depending on the objects around it, is what we call gravity, but really it's all just dark matter.
I lost you there.
That's what I'm saying. Are you seeing how I'm trying to put it?
Yeah, and you're wrong.
But but I'm not saying that. But you can't say that I'm wrong.
Yes, I can.
No, you can't, because there's
dark
no.
matter isn't gravity.
I'm not saying that though.
What you're
That's
saying
not
is,
what I'm saying.
What
But
you're
it
saying
does cause
is
a gravitational effect.
correct.
That's not what I'm saying.
You're
That it
saying
is gravity.
that instead of us walking, okay, going back to this analogy.
My terms are just the terms of what I'm saying are just you're misconstruing what they
Gravity?
are. No, that's not what I'm saying.
It has to be.
What
It has
did
to be
you, that's
360
exactly what you
degrees.
just said.
No, yes, but I'm not saying that it is gravity. I'm saying that we quantify gravity as something as what is, but I think for what I'm saying to be
you just had a
true.
stroke. Good
I
Lord.
think I
It's an
did.
attractive force, for the most part. There is some
To an
force in
object
gravity.
though.
To anything.
Mass.
On an object, but
Mass.
I'm not saying, but what I'm saying is not that. All I'm saying is that dark matter is this physical wavelength that we call that
Yeah, I see what you're saying, but
yeah, when you look at the diagrams and stuff of what they assume that we are moving through this plane of space and time, and things are shifting and
well,
moving,
I have my doubts
and
about
space and time is moving around certain objects, and But what I'm saying is, what we say is space and time is just that dark energy expand. I mean, because time has to be relative to movement. So, and space is space, right? So if
What is, what is
But-
space?
that's what I'm saying is the dark energy is the whatever you want to call it, dark energy, dark matter. They're not two different things. It's the same thing. You're just calling it. I've never heard anybody say
No,
Well,
there's
two
dark
different
you're
energy and there's
calling
dark matter.
Ether. What you're doing, you're calling it ether.
Yeah.
What do you mean? Ether is like
ether was an old,
like an alcohol.
They knew something was
No.
out there, but they didn't know what it was. They call it ether.
It's like
yeah. Essentially, I'm saying that dark matter is the plane in which we exist on. It's not. It's we exist on on this plane of space and time, which we call dark
we
matter.
should be able to measure it then. And we
Maybe
can't do that.
not
We
yet.
can measure its effect.
Not
we
yet.
Can't measure it itself.
100%. There's plenty of things that we can
It's like
that we
gravity.
can
They have
measure,
no
but we
idea what
can't say why it
gravity is.
happened. Well, yeah, that's what I'm saying.
I think gravity is just a bunch of magnets.
You think it's just different
well, the
magnetic
one thing I was trying to get
pools.
at
We
before
have
was that when you have a map showing you space-time, it's 2 dimensions. It's flat.
yeah.
But if you got a large mass, it's attracting from all sides,
Yes.
and you only see one.
Yes, in the diagram they only show you the one.
But in reality, it's got to be 360 degrees all around the mass.
Most definitely. So just turn that diagram every which way.
No, because you need to see it all at once.
It's impossible.
The same like
No, that's fourth
M85,
dimension.
the black hole
Yeah.
we took a picture of.
Which is not a dimension that in our existence we live on
We
and can observe.
We can make four-dimensional objects. Look up your phone. Four-dimensional.
Space
objects.
is the only place there's a fourth dimension.
No.
No, what are you talking about?
Where is there a fourth dimension? How do we make four-dimensional
Counting
objects?
time is a 4th dimension.
Okay, but how do we make fourth-dimensional objects? What are we making?
Get a glass box. Put a glass box inside that glass box. You now know what's inside the glass box without even opening the box. You can see it. You can see all of that object at the same time, know exactly what's in it, what's around it, what's behind it, side to side, yet it's just there. It's closed.
That's a
3D object, but
that's-
in a four-dimensional state.
Yeah. Yeah.
Yeah, I guess if you want to cheat, I get that. That makes
What are you
sense.
talking about cheating? That's literally a fourth.
So I need to buy a glass box instead of glass.
You need to
box
look
then.
up fourth-dimensional objects and go buy one on Amazon for about $15. It's a paperweight. It's great.
Oh man, that's crazy. I did want to bring this up too. One, you should start going on. It's called Quanta Magazine. It's online. It's called Quanta Magazine, and they give you science updates and new discoveries and things currently. And they just discovered. Essentially, they discovered the largest supernova to ever be observed.
It's okay, that's the last 200 years.
Yeah, so what's cool, though, is that we've never been able to observe something this size and to
That
see...
happened 2 years ago.
Well, we just found one bigger, is what we're saying. But we're saying we're at the point where we can observe it collapsing in on itself.
Yeah.
Yeah,
Because
now.
they got different telescopes all keyed together all over the world.
Yeah.
So you got a very large
And it's at the
telescope.
point where we caught it just at the right time to where we've seen it at its almost peak size.
And then collapsing.
Well, we haven't observed that yet,
Uh,
but because it hasn't, I mean,
Right now, it's just probably a red
it could take
giant.
20 years, it could take 20 years for that, but we've,
Take
not according
1,000
to what I
years.
heard. Once the sun or the star starts producing iron, it collapses almost immediately, within a second.
Well, it's not there yet. Well, I mean, I guess it would be there because if we're seeing it and it's 46,000 light years away, then
Burst of light, it might be just a minute.
yeah,
It's already gone.
it's
man.
already gone. Yeah. Well, it was gone 46,000 a million years ago. Really, to be honest.
That thing was alive when the dinosaurs were.
Exactly.
But
Yeah.
not now.
But not now. No. But we're finally we can observe. We're technically going to be. We have the capability to observe it doing its thing, which is super cool.
Yeah.
We've never been able to observe that moment itself happen.
Well, that's not surprising.
And with that moment,
It's 'cause we
though,
have such bad timing.
yeah, but when it happens, think about all the things that we're going to learn from it. We've never seen it. We've always just made assumptions on what happens after. We've
We've seen them erupt, nova, when they get huge.
This is saying that we've never
seen
one collapse on itself.
We've never seen one
We just know the
start
before
the
and
supernova. We just
Yeah.
know what happens.
what happens
afterwards.
after. Yeah. Yeah, no, they're saying that they've discovered one that's about to happen, so we'll be able to observe it happening.
Well, good luck. Keep looking at that thing for about 60 years.
Yeah, it was, and then this one guy was talking about, like since we were talking about like science and then and now, the basically like the technology of like from digital, like from how they observed, like they pointed the telescope here, and then they had to wait, and then all these statistics came out, and then they had to defrag all of them and basically put them all in the right place to see what this thing is or how big the object, and do the mathematics, right? And then they were saying that the first, when they were looking out to see, because you've heard of Planet 9?
Yeah, they never have found it.
They haven't found it yet, but they're looking. They're technically, they're saying
Something about Jupiter doing something it shouldn't.
Yeah.
Yeah, well, basically, well, yeah. Essentially, that they're saying that there is a planet out there, but it doesn't move in our orbit, and that it doesn't move in the same orbit. It has a completely because this moves this way and whatever, right? However, all the planets move around each other. They move at a certain speed and distance based on where they are on the plane, right? Whatever. But this one moves, like Pluto never moved on the same axis as all the other planets, because once it got towards Neptune threw its gravitational whatever off, and it moved differently than the other planets. And another cool fact is that there could never be a new planet. Like a new planet could never come in. Like you couldn't take a planet and put it anywhere, even though there's thousands of whatever millions of miles in between.
You could just off kilter everything else.
It wouldn't but it wouldn't off kilter everything else. Everything else.
What are you talking about?
No, it would just send it off into a different area, because
I guess
our gravitational.
You have a rogue planet coming from a different
because
part of the universe.
because the minute that it got into our solar system, it would just get spit back out because.
Not necessarily.
Yes.
Depending on the angle. How it comes in.
Where do you think we got
We're
the
already
asteroid
full
belt
of
from?
planets.
Huh?
What do you think?
We're already full of planets. You
Not
can't
full.
add another planet
Why
into our
can't
solar system.
Asteroid
Why
belt,
can't
dude.
you?
Because the way that the sun and all the other planets are at a certain distance and at a certain spin and at everything, and that if anything came in, they would immediately eject it. It wouldn't work.
Not necessarily, but I can see your point.
Well, it's
but
not
it
my
could-
point. It's science's point.
No,
That's
I don't
what-
know.
That is a scientific. You can't say anything is fact, obviously, but that is a measurement that they're saying it is physically impossible for another planet to ever enter. We can never have any more planets to what we have.
You know
now.
You know about the
It's
asteroid belt?
impossible.
You know about the asteroid belt?
Those aren't planets.
There are planet-sized rocks
Yeah.
hurtling around
And
the
you
sun,
know what? And you know
we
what?
get more
Bigger
of
than
them
Pluto.
every year.
But you know what, though? You could fly in that asteroid belt for the rest of your life and never run into an asteroid.
You
Do
find
the
a
same
new
thing
one.
in our solar system.
For sure. But what I'm saying is is that scientists say, not me, not you, not us that don't know anything, but scientists who use math say that it is impossible for
I have never
another
heard that.
planet
I
to
haven't
ever
heard
get
that.
in here. Well, I'll show you the thing so that you can listen to it. Anything that I ever send him, he doesn't even listen to it. So
Do you
I'll
think
send
I
it
have
to you.
time like that? What kind of life do you think I live?
You drive around in a car,
Yeah, that's not the only thing I do.
but that's
So do you.
Yeah, and I listen to these things all day.
I don't got time like that.
This is all I listen to all day is science stuff. But yeah, those are two things.
Well, you ought to go on a World Science Festival.
Yeah,
on
I've seen a
YouTube.
lot of those. Yeah, they're good.
Especially Brian Green. I love him.
Yeah, I was just listening to Brian Greene talk about string theory today. There's a, it's not, I guess we're going to say it anyways, but there's a podcast called Mindscape, and it's that guy Sean Carroll's podcast, but he interviews scientists and different things like that, and technically all of his credentials are in astronomy, but everything he does is towards theoretical physics. So he got a different job. Basically, he went to school and then ended up getting a different job. That's all that happened. But he talks to and he was talking to Brian Greene, and Brian Greene said that that basically he's like, I'm ready for the answer to string theory, to whether or not he's like, it would be great if it was real. Obviously, he spent most of his
Yep.
most of his life
1985.
and is just working on this and claiming this theory. But he's like, at this point, I don't care if it's right or wrong. I just want to know.
Just want an answer.
And he's like, but that is the beauty of science, right? Is that everything that we've talked about and everything that we said could be completely wrong.
Yeah.
And it could, yeah. That's the beauty of science, I guess. Is that nothing is finite.
The only trouble with string theory and parts of quantum mechanics is it requires multi-universes, multi-dimensions.
Yeah, string theory, yeah. And they don't even know how many. They
12.
go from 12 to 10 to
Well, you
24
got the
or
4
16.
normal, then you got to have 9 or 8 others, whatever.
And then there's obviously there's shapes and things that they talk about that the different universes are basically run through different
Extremely
shapes.
small, itty bitty.
Yeah. So it's
That's what we can't say.
it's very it's almost like believe it
Sounds
in
like
God.
somebody was doing a lot of
Right?
pot that night.
Yeah. Somebody somebody smoked a bunch of weed and
That's it, man.
had some
Hey,
deep
that's the answer.
thought. Yeah. You think Einstein might have just been a really big pothead?
He always smoked a pipe.
Yeah.
Did he really?
Yeah, he
Yeah.
did.
Oh,
That's
yeah.
why when you see the T-shirt at Hot Topic, he's smoking a pipe, and you see that rainbow smoke coming out or something like that.
Yeah. he was just getting really high and thinking really deep.
Hey man.
Well, yeah.
Good. He was an amazing man, though.
That's
Yeah.
true.
What they say, even when he was wrong, he was right.
Do what?
Even when he was wrong, he was right. Because he,
Yeah.
a long time ago back in the day, he
He
came up
predicted a universal constant.
constant, and then stuff came
Yes,
out and it
my
was
biggest
wrong.
mistake, and they find
Yeah.
out that's
He
a
even-
black matter or dark matter.
Yeah, and he even wrote a whole paper discrediting his own self. Like, I should have never have come up with
Yeah.
this theory, blah, blah. And then, in the 70s, 60s, they were like, oh, Einstein was right. Yeah.
My bad, bro.
Yeah, whoops.
Yeah.
Sorry, buddy. He doubted himself.
Like-
You know what stinks is but who would you bring back? If you could bring back one, would you bring back Newton or Einstein? Newton did it without any tools, any
Nothing.
science. He just thought it all
Nothing.
himself.
Nothing.
So wouldn't that be the guy you want to bring back over
No,
Einstein?
I'd bring
No,
Einstein because Einstein's
no.
more up to date.
Yeah.
I mean, Newton would have to get
Well-
caught up. He'd have to get caught up first.
You would have to catch Einstein up too.
Well, I mean, you would.
I
have
mean,
to
I guess
catch-
we do go based a lot of everything off of what he did, so that's true.
And
Yeah.
they can't find him wrong.
Yeah, but who was a better thinker?
I would say
Newton,
for sure.
right? He thought
Yeah.
he
Oh,
had to
yeah.
think harder and deeper,
Oh yeah.
and just imagine if we had somebody in this world
If
with a
only there was a
brain.
way that we could somehow fly through the air like bird. That's a plane. That's a plane.
You said, well, how do what's that noise I hear outside? This is a car. What's a car?
Exactly.
Yeah,
Oh, that's how we get
Well,
around, you know. It's
we. You would bring Newton back,
Well,
and he'd be
we-
like, because he thinks so deeply, he'd be like, "What's a car? How does it work? What's an engine?" You'd be like, "Oh, well, there's this engine, and then there's pistons, and then the fuel goes in,
Why
and there's
does it
a
work,
combustion
though?
season." Yeah, exactly. Yeah, what's the fuel? He's like, "Why are there no horses?" Yeah, where are all the horses?
How
do
many
you guys get
horsepower
around?
did you say this was? 30? You can't fit 30 in there.
Yeah, yeah. Where's 500 horses in this? And why do we call this a Mustang? This is not a Mustang. Yeah, that's true. He would be.
You'd have to get him caught up.
Yeah.
He would immediately die. You would bring him back, and his brain would explode with questions.
I think so.
How crazy would that be to know nothing? You know what's a really good show? What's a movie that I watched last night?
The table.
Is sorry, you can hear that. So a really good movie, and it just came out on Netflix. It was super cool, and it's basically about these people. This guy who's a scientist who's looking. These hippies went and looked for the fountain of youth, and then they went into this cave, and the guy went to go look for them, and then he went into the cave, and his students went into the cave, and they basically once they went in the cave.
The sharks ate him.
No, they were like going through the cave, and then their rope broke. They got trapped. They had to go out, and there was only one way out, which was this thing. And when they're looking at it, up into this where they can see the light to get out of the cave, it's like the light is coming and going and coming and going and coming and going, and then they're like, and then they send somebody up who this girl free climbs up, and then she comes out, and everything is like dust and sand and dirt, and then she climbs back in, and then she looks at her camera like she filmed it. She was up there for like a half hour, and then on the guy's camera she climbed up and immediately came back down. So the cave itself, like time stopped within the cave when you left the cave. But then basically they were like, oh, it's just days going by, right? So we've only been down here for maybe a couple months, right? But then they re-looked at the camera and they saw that there was like snow and whatever, and the seasons they were years. And then at the end of it, they basically jumped like 300 years into the future. Not intentionally, because once you go into the cave, you can't get back out.
Okay.
And the cave had different levels of time. So the deeper you went in, the slower time moved. It was
No,
That's
super crazy.
That's Einstein.
Super crazy.
If you live in a basement, you'll live longer than a person who lived on the top floor.
100%. That's a fact, right?
Yeah, you won't fall out of any windows.
All right, on that note, that was Chocolate Smoov and Chapstick podcast. Follow, like, subscribe. I can't say that word. We talked to the great and powerful Ed.
Love you, buddy. Thank you very much.
Thank you.
Yeah,
Thanks
it
for
was
doing this.
fun.
We
We'll do this
appreciate it.
again.
Most
Yeah.
definitely. We'll have you on again.
I got to be able to say a few of my weird thoughts about the white hole.
Mm-hmm. Which, depending on you ask, that could be a dangerous conversation.
Yeah.
All right. That's
Oh, okay, it's time for
Game of Thrones.
Game of
Bring on the story.
it.